Right?
Oh, Triv,
Yeah.
you never guess what these nerds over there just did.
What nerds? Go on.
You know Einstein's equation of relativity equals mc squared.
Yeah. Oh.
You know, they thought they were doing physics,
Right.
And what they did is they said E equals m, right?
Yeah. Right.
C
Uh-huh.
delta theta. What idiots! They're so.
Wait, you
they're
know,
so-
that's another equation, isn't you? Sorry, I had to fix Wayne. Occasionally this happens. He forgets that he also did chemistry and they're not separate, like French or German. It's
it's a good equation.
So who were the nerds then?
It's me. There's a mirror.
Oh, I see. That's sad. That is.
Silly.
I'm glad we got that sorted. So now we can go on to this equation.
It's a lovely little equation.
Yeah, Einstein didn't make this one.
He didn't.
Don't know who did
He's a
actually.
pretty clever guy. It was me.
That's it. Just well done, Wayne.
Well done, me. Eh?
Don't know about the course. It's all Wayne's work. So we have a look at this equation and what's in it. So first, what is the C if it's not speed of light?
It's the specific heat capacity of the subject at that time, which is normally
Great,
water.
cool.
Normally,
So what's that?
well, specific heat capacity is like the energy required to raise a unit of mass, normally 1 kilogram,
Yeah.
by a unit of temperature. And if it's 1 kilogram, it would be 1 degree Celsius or Kelvin, because the gaps are the same for both.
Yeah, and it's a useful thing to know when we do the delta theta to do with temperature.
Yeah, delta theta is change in temperature.
Yeah, the change will be the same in Celsius or Kelvin because they'll be the same increments in the scale.
And that's an important thing to realise. You should really do it in Kelvin.
Yeah,
but it
because
doesn't
it
matter.
yeah, that's in Kelvin. But there's a few things you need to know about specific heat capacity. There's one that you just have to know off your head. One of water. That is 4.2 kilojoules.
Yeah.
Kelvin.
That will always be given to you in a question because the actual value is about what
4,100
4,100 and something.
Yeah.
So that will be given to you in a question, and that changes for different things.
Yes, that's only water, that is. Yeah.
The mass is the mass of the subject.
Yeah, so
that
if
you're
it,
heating.
if it was water, it'd be the mass of water.
Yep. So that's an important thing
Yeah.
to notice there.
So, all this in mind, I think we should do a work example, Wayne. Go on.
I have a neat one over
Yeah.
here. Yep. Yep. You see, OCR,
Yeah.
they have a love of dishwashers.
Do they?
Yep.
I don't love dishwashers, actually.
No, I like washing dishes by hand.
Yeah,
It's way better.
that's the way to do it.
Anyway, a quantity of hot water required for one part of a cycle in a dishwasher
Yeah.
is 4.5 litres.
That's not much as I thought, actually.
4.5 litres.
Thank you.
The inlet temperature of the water on a cold day is 5 degrees Celsius.
Okay.
Which is actually quite a cold day. Yeah, I'll give them that.
That's
done,
quite
OCR.
nippy.
Yep. And is required in the machine at a temperature of 65 degrees
That's
Celsius.
quite a big change. Then.
So it's put in at 5 degrees Celsius because it's cold, but it has to be heated for 65 degrees Celsius to wash your dishes.
Yeah, so there will be a change there of 60.
We're already on there.
No, that's good.
The time allowed for heating the water is 15 minutes.
Okay.
It says the time allowed. I'm not sure what happens if you go over that time. Maybe they get like a detention or something.
I don't know, you get in some sort of trouble.
And the question is, what power of heater is
Okay.
required? So it's a power question. Now it tells you the specific heat capacity of water is 4,200 joules.
Mhm.
So as Triv said, that's 4.2 kilojoules. Be careful
Yeah.
with that. And it says that 1 litre of water has a mass of 1 kilogram.
And that's something you should just remember, but yes, that's true as well. So that means straight away you should do some conversions.
You should.
So, let's do that. So 4.5, as said there.
Yep, 4.5 litres of water will be 4.5 kilograms.
It
Nice
will.
and simple. Because a volume of water isn't going to be much use to us in any equations that I know.
No.
As Triv said, this thing becomes the change in, that's what we need, and that is 60, as Triv
Yep.
very cleverly calculated.
Thank you. And 50 minutes, you want it in seconds, so that's 900 seconds.
Yeah, 15 times 60. Quick maths there.
Thanks. 5 minutes at 300, just a good thing to remember that.
That is actually. Well done you.
Thanks.
So we're trying to work out power.
Okay.
And we have
An equation.
An equation.
Yeah, and this gives us energy. Now we know that energy over time will give us power.
Exactly.
So we'll find the energy and then we'll divide by the time.
So let's go ahead and do
Let's
that.
do that. So we need our mass of the subject, but that's our water here, so it's fine. It's 4.5.
4.5, that's why it was
Always in
useful to-
kilograms here.
Yeah.
Then times by this, it has to be in joules, so it'll be 4,200 there.
Yeah, so 4,200 is given to us
Yeah.
It's given that to us in the question, so we
Yeah.
don't need to say the actual 4,190, whatever,
Yeah. And we times that by our change in temperature.
which is 60.
Yeah.
And you know what? I'm just going to find out the answer.
Because I don't know what that is top of my head.
It is. Let me just find out. Oh god, they haven't done it differently, have they? No, 1.13 times 10 to the 6 joules.
1.13 times 10 to the 6th. Okay, now we need to divide that by our time.
Yep. Just be careful in your exam, because when it gives you this sort of question, the answer will be in watts, because it wants power.
Yeah.
So you just need to be careful to make sure that you know yourself that this part is measured in joules. So you know power is joules per second. Just don't,
Yeah.
if you put it in kilojoules, that's fine, just be careful to convert it back.
Yeah.
So just be aware of that.
So we divide it by our time.
Yep, and we've worked out our time in seconds. We know that watts is joules per second.
So that's all good.
And with that divided by 900,
Is another value
it is
which is less than that.
1,260 watts. And
So that's the power there.
yeah, so they like to do that sort of thing, rather
Yeah.
than just simply asking for something. They like it when you combine one or more equations.
Yeah, they like, you have to notice, you could have done this, okay, I guess it is what we did, but we were essentially substituting RE for power times time,
Yeah.
because that will, cause power is energy over time.
Yeah. Joules per second, we know that.
Yeah. So you times that by time, it just gets joules, which is our energy, so that's why we can have power times T is equal to E.
Yeah.
And that's quite handy. That sort of thing I like to notice for the exam.
And so they like to do water and stuff, that's a
They
good
do.
one. But they like to do metals, which is a different sort of setup that we'll just briefly talk about.
Okay.
It's when you put you have some sort of metal,
Right.
it's in some sort of insulator, so that the minimal heat is lost to the surroundings. You heat it up with some sort of heater, you record the temperature, and you record that against time. So you might have this all being electronic and set up to draw you a graph.
Yeah.
And the graph will have temperature against time.
Yeah.
So, you know, that might look like that, I don't know what it looks
It will,
like.
there will be a curve of some description, I imagine.
That's really confusing. That's temperature, I did say that, but I'll just put it capital T, because they're both in T.
Yeah.
Temperature against time. So the gradient of that is temperature, delta theta. We're thinking, I forgot what things meant then. Delta theta is your change in Y
Over time.
over a time.
Yeah.
And just be careful, you know, about that being the gradient. So you substitute that back into the formula. Might be something they ask. And this sort of setup they might ask about.
Yeah. So you might have to work out, say what the C was from the power of the circuit or something.
They like that sort of question. It's just substituting things in.
Yeah.
But that's specific heat capacity, and then we go on to specific latent heat, I think, next.
Yeah, I think we're late for that, Wayne.
Oh my god.